Hello and welcome to video number 4, in which we're going to be looking at fitness within the context of evolution. So what the deuce is fitness when we are talking about evolution? Well, a key element of evolution is this concept of fitness, and fitness represents the variation in reproductive success within a community, and it is the fitness of organisms that underlies that variation in reproductive success. So if we want a definition, fitness is essentially the relative lifetime reproductive success of an individual. I've put an alternative definition on this slide for you. The fitness of an individual is a measure of its ability relative to others to leave viable offspring. Sometimes, for what it's worth, reproductive success is also referred to as fecundity. So if you see the word fecundity, that's what it means, just lifetime reproductive success. You may see fitness as a word applied to a genome or part thereof, to an individual, to a group, or to a population. And it's quite hard to quantify. Sometimes it's best thought of as a probability. So the probability that you will breed and pass on genetic material. It's impacted on by factors such as how well suited an organism is to its environment, the individuals any given organism is competing with, and anything else that impacts on survival and reproduction. So there are lots and lots of different factors that underlie the fitness of organisms. There's a fantastic example, I think, on this slide here of two lizards that have used very, very different colour schemes to improve their fitness. And these colour schemes improve their fitness in fundamentally through different mechanisms. So they both have the same ultimate result of higher fecundity or higher reproductive success. We'll talk about in the Zoom session how these two different colour schemes may work. But I would encourage you to have a quick think about it. Why is this one bright and colourful, whereas that one is dark and woody coloured? And after this slide, I'm going to be cutting into this video a really fantastic video from a study that was conducted in the US that actually links within bacteria mutations to fitness. And the video explains how they've done this, and I think it's a really, really nice example of the link between mutations and their ability occasionally to improve fitness. So I hope you enjoy watching that. And that's it from me for this video, so I'll see you in the next one.
So what we ended up building was basically a petri dish, except that it's 2 feet by 4 feet. And the way we set it up is that there are 9 bands, and at the base of each of these bands, we put a normal petri dish thick agar with different amounts of antibiotic. On the outside, there's no antibiotic. Just in from that, there's barely more than the E. coli can survive. Inside of that, there's 10 times as much, 100 times, and then finally the middle band has 1,000 times as much antibiotic. And then across the top of it, pour some thin agar that bacteria can move around in. The background is black because there's ink in it, and the bacteria appear as white. First, you see they spread in the area where there's no antibiotic, up until the point they can no longer survive. Then a mutant appears on the right. It's resistant to the antibiotic, it spreads, until it starts to compete with other mutants around it. When these mutants hit the next boundary, they too have to pause and develop new mutations to make it into 10 times as much antibiotic. And then you see the different mutants repeat this at 100. And after about 11 days, they finally make it into 1,000 times as much antibiotic as the wild type can survive. And so we can see by this process of accumulating successive mutations that bacteria, which are normally sensitive to an antibiotic, can evolve resistance to extremely high concentrations in a short period of time.